Howdy there, Internet students. This is Mr. Hermanson here. We're doing lesson 10.4 on the perimeters and areas of similar figures. Couple of words we should quick review. Go ahead and write your answers to numbers 5 through 7, and you can check back and see if you got them right. All right, just to kind of make sure you understand what's going on here with the scale factor and the ratio of the areas of similar polygons. Let's do a few problems here, and then we'll use that paper on the next page to help us figure this out. I'll give you some examples of rectangles to use. So go ahead and find the perimeter and areas of these rectangles. You should have got those answers. Now notice that there's something going on with the areas. So let's look at the scale factors of each of the ones we created to the original. The scale factor from 1 to the original would be 6 to 3, 8 to 4, but in lowest terms 2 to 1. 2 to the original would be 3 to 1. And the third one to the original would be 4 to 1. The ratios of the perimeters would be 28 to 14, which is 2 to 1 from 1 to the original. From 2 to the original would be 42 to 14, which is 3 to 1. And 56 to 14 would be 4 to 1. So we see that the ratios of the perimeters are the same. The ratio of the areas 1 to the original would be 48 to 12 or 4 to 1 in lowest terms. The second one to the original would be 96 to 12, which is 9 to 1. The 8 to 1, I guess I should say on that one. I did my area wrong on the second rectangle. It should have been 108. And then the ratio would be 9 to 1. And the last ratio, 192 to 12 would be 16 to 1. All right, so how do the ratio of the perimeters and the ratio of the areas compare? Well, if you take the scale factor, the ratio of the perimeters will be exactly the same, but the ratios of the area is the scale factor times itself, you might notice. So that's what we're going to use to help us figure out problems today of similar polygons. That if the scale factor of two similar figures is some fraction, let's say it's 1 to 3, whatever, then the ratio of their perimeters would also be 1 to 3, A over B, but the ratio of their areas is the scale factor squared, which would be 1 to 9. So just going over that again, let's say that our original scale factor is 2 to 3. The perimeter would also be 2 to 3. The area would be that number squared, or 4 to 9. All right, so finding those ratios in similar figures, the ratio of the smaller to larger of perimeters, and when you write these ratios, when you put your answers in your work today, your practice, let's use the form where you have a colon. So we're going to compare 6 to 8, smaller to larger. Simplify, that would be 3 to 4. For the perimeter, the same as the scale factor. And then the areas would be those numbers squared, which would be 9 over 16. All right. If two similar polygons have corresponding sides in the ratio to 5 to 7, what is the ratio larger to the smaller of their perimeters? What is the ratio larger to smaller of their areas? Go ahead and do that. All right, so we can use this idea to help us quickly find the answers to problems. We don't even need to find the area. We can just use the scale factor. So of these two similar items, the scale factor is 7 to 10. And we want to know what is the best approximation for the area of the larger regular hexagon. Well, the areas will be the scale factor squared. So we're not going to use 7 to 10. We're going to use 49 to 100. So, and then I'm just going to set up a proportion 49 over 100 equals, the smaller area is 127.3. And so then we're going to just cross multiply and divide. And we get 259.8 is the closest answer. We round to the nearest 10. All right, why don't you try one here and see if you get the answer right. If you did it right, you should have got 54 square inches. All right, so this, since carpet is installed in a room according to the area of the room, we have to use the area ratios to figure that out. So if the carpet is installed in a room that's 12 by 15, how much would it have to have her install it in a similarly shaped family room with a larger dimension of 18? So our scale factor is going to be 18 to 12, large to small, which simplifies to 3 over 2. But our area factor will be those numbers squared, which is 9 over 4. So if the smaller area costs 150, the corresponding larger area will cost in the ratio of 9 to 4. So we're going to solve that by cross multiplying and dividing. And we get $337.50. All right, see if you can figure that out. Figure out the cost of the glass using the scale factor. Now glass you would buy by the area. Using the ratio of area to figure out the cost of the larger piece, rounded to the nearest cent, you would get $6.94. All right, so finding perimeter ratios. Perimeter ratios, remember, are the same as the scale factor. And if you have the ratio of the areas, then you want to do the square root of that, and that'll equal the ratio of the perimeters. We're working backwards. So if the areas are 32 and 50, that would be the scale factor squared. So we're going to do the square root of 32 over 50. Now 32 over 50 I can simplify. That equals 16 over 25 simplified. And that works out nice because both of those are perfect squares. And so the ratio of the perimeters, which is equal to the scale factor, will be 4 over 5. All right, see if you can get that. Try to leave your answer in simplest radical form if it doesn't work out perfect. All right, here's your answer on that one. And go ahead, you should be ready to do the practice. And we'll talk to you later. Good luck.